Hello, everybody, and thank you so much for joining us today. And all right, I'm going to recover from the panic of not having my audio. Okay, so yes, the elusiveness of ethics, encoding fairness in an unfair world. Just briefly, thank you very much, Adina, for that intro. I am the founder of Debias AI. It's a new organization working specifically on tools for product people and developers. So I'm very interested in like how we make product decisions on the daily level, not necessarily at the framework or strategy level, or perhaps more specifically, how it flows down. Also, I am the creator of Ethics Litmus Tests, which you may have heard of, and the girls have not told you, I am giving 2 of these packs away for people who complete their surveys. So do please complete your survey about the event, because you will go into the running to win 1 of 2 of these packs, which hopefully will be fun. If you want any of the links in my slides, go to the master, which is up on GitHub, and you can get all the links, and I'm sure we will share these around later as well. So don't fret. I do have a lot of resources that I share. Don't stress if you can't catch them as I go, because I'll make sure that you can get access to the slides with all the links later on. Okay, so a couple days ago, I was talking with my reading group about this paper called Desanctifying the Charisma of Numbers. And it was actually a lit review, and it was comparing these 2 books. One is called Calculated Values by William Derringer, and the other is called The Tyranny of Metrics by Jerry Mueller. And interestingly, both of them, they're focused on these sort of questions of like metric fascination, or this fixation with calculation, whether it's good or bad as a sort of political, social impact on the world. But one of the things that came out for us in the chat was this idea that there's at least 2 distinct kinds of problems with metrics or metric fixation. One is like the things that we often talk about, like the problems of calculation, the problems of getting the number right, not gaming it, not making it vanity metrics, like actually finding useful ways of measuring the world. But there's another one that is easy to forget, which is like the problem of framing, like the problem of asking the right question in the first place. And I always think of that classic line from Douglas Adams, like, you know, what is the meaning of the world, the earth, the universe, and everything, 42. Well, if we don't know the right question to ask, we won't necessarily get a useful number out. So I think this is important to keep in the back of our heads, is like when we're grappling, particularly with machine learning, we have like these 2 big problems going on at all times: the problems of calculation, how to get the right numbers out, but also like more broadly, like asking the right questions and framing them well. And following on, and perhaps compounding that impact, I'd argue that when we do this work, like with data science, with machine learning, with any kind of analytics work, we often mix up whether what we're doing is descriptive or normative. So what do I mean by that? What is descriptive and what is normative? Descriptive is this sort of scientific concept, meaning when I observe the world, I make a statement about it, I maybe capture notes about it, and I say, so for example, here what I'm saying is girls wear pink, and I can see 4 girls and they're all wearing pink. So this is a descriptive statement, because what I'm doing is actually observing exactly what's happening in the world and capturing it as precisely as possible. Whereas if I am looking at a girl who's not wearing pink and I say the words girls wear pink, instead what I'm doing is I'm exerting a normative force. So I'm basically making a statement about the way I think the world should be, not necessarily the way the world is. And this may seem a little bit abstract, but hopefully I'll like tie this together for you as we keep going. So bear with me if that seems a little bit abstract at the moment. Oh yeah, I just said that. So for an example, one of the uses of machine learning and image classification we're seeing more of these days is this use of drones and video technology to do infrastructure maintenance. So in this image that I'm showing you, we're looking at a drone that's looking at a bridge. And what it's doing is observing the state of repair of the bridge and fundamentally looking to see like if it needs repair workers to come out and take a look at it, or if it's okay for some further period of time, like days or years. And I think this is interesting to like think about from the descriptive versus normative point of view. Like what it's saying is it's making a measure of what's happening with the bridge. So like you could say there's a purely descriptive force. It's observing what's happening with the bridge. But then in the technology itself, there's also going to be a normative statement somewhere. There will be a threshold, there will be a guideline. And at that point, it will say, if we see more than X degrees of damage to this kind of, this brick or something, then we need to go repair it. So that's a normative statement. It's making a statement about the way the world should be, not the way the world is. And so I think, like, you know, you think about bridges or infrastructure, it's very impersonal. It seems like not very human. So maybe it's a little bit like less scary to say this, but we make normative statements about the world all the time in every kind of technology that we design. In fact, I'd argue that, like, in many ways, technology is just normative statement generators. So the fact that when I sort of push back and ask people, hey, what's the normative statement you're making, or is that okay? Is that an appropriate thing? When we talk about human behavior, interactions with humans, people sometimes get a bit uncomfortable, but like arguably we do this in every aspect of life. So I think it's quite important for us to get comfortable with the idea that we're making these normative statements and to query what they are, to ask if they're okay. So yeah, if you ever do get pushback on someone saying, oh, I'm not sure we need to have this conversation, or, oh, I'm not sure if this is like in our purview or in our domain to talk about, I think I encourage you to try and use that example, because I think like this normative descriptive is something that we need to get really clear on. I'm not going to play this video for you, but I just wanted to highlight that it's hilarious, and it actually very nicely states something that has been mulling around in my head for a while about like the nature of particularly black box algorithms, like particularly untrained deep neural networks that are very hard to understand. So I'll take you straight to the kind of learning that I got from the video and let you watch it on your own time. And the learning that I got is that particularly in the specific style of machine learning tool, the pursuit of profit is not the same as the pursuit of knowledge. And that's an interesting divergence to observe, because in most forms of science and maths and statistics, the more you know, potentially the more profit you can make. But in these particular styles of models, we can potentially win at a game without necessarily understand how we're playing that game. And I'm obviously speaking in reasonably high level terms here, but I think it's an interesting thing to consider when we talk about machine learning, is that unlike other areas of technology and science, winning may not be the same thing as understanding, and fundamentally understanding might be a whole other job. Oh, and this refers to a thing in the video, which is they're talking about a mousetrap, and and I'm asking the question is, can a mousetrap be unethical? And I think, like, you know, it's easy to think of tech as, you know, just this thing that's like, you know, catching mice or doing something reasonably like utilitarian, let's say. But in my opinion, you don't have to scratch the surface very far to find ways that, yes, it could be unethical. And like, for example, if your mousetrap only caught pregnant mice, would that be okay? Maybe not. So before I go into the section where I talk through all these different kinds of bias, I want to pitch you a couple of like big hot takes, and you may disagree with me, that's totally fine. But I think like it's maybe helpful so that you can frame the world and sort of hopefully enter you into the way I'm thinking about things a little bit. So in my opinion, as we're building these machine learning systems, and specifically in a capitalist corporate context, so not so much for academic or research purposes, but specifically to make products in the world and sell things, I would argue that there's no prediction, only intervention. And I'd say that because I think what we're doing is trying to like identify what may happen in order to intervene on it. We're never predicting purely for knowledge's sake. We're predicting for the possibility of intervening and making some kind of capital gain from it. And to extend that, I would argue that classification is never descriptive, always normative. That the classifications we're making from these models are creating more than a descriptive force in the world, they're creating a normative force. And that's part of the ethical question we have to grapple with is that okay? whatever style of classifications we're making, like, is it okay that we're not only observing what's happening, but possibly exerting some force or some form of idea about what the world should be going forwards? So the thing I'm trying to say to wrap it all up is I think that machine learning models are usually normative and interventionist when deployed within a capitalist framework. And if you want to argue with me on that, please do. I would love to hear it. Okay, so I want to talk now about taxonomies of bias. I'm going to spend the rest of the talk basically explaining some of the different ways we can name and identify and think about mitigating the kinds of bias that can occur in a machine learning system, but keeping in mind like this normative force and this interventionist force and whether these things are okay. And a lot of this work is drawn from a paper, which you can go and read further. I tried to basically make it friendlier and easier to approach. So first of all, we're thinking about two primary forms of harm. And these are allocative. So that means whether or not someone is allocated something. So it could be something that's a positive, like whether or not I get a mortgage, whether or not I get, could be a candy, could be something little or something big. Or it could be something bad. So it could be whether or not I remain in jail for longer or not. And the other kind of harm we can think about is representational harms. So this is like the classic, you cannot be what you cannot see. If you have people missing not at random from your data set, you may possibly be causing them harm in some way by not representing them, but not learning about them. And obviously, there's lots of problems with people not being seen in the data. So I've drawn a map, which I'm hoping will help it easy to think about the forms of bias that can occur in a machine learning system. And like, to be frank, any kind of system that uses big data and is trying to automate a decision at scale, it doesn't have to be purely machine learning. I think this applies to most of data science, to be honest. So we'll start with the data source. So basically what we're doing is looking at the world and we're asking the question, is this good training data? Do we actually want to learn from what has happened in the past? And I think this is a question we don't ask enough because it's important to recognize that not all data represents good decisions or patterns that we want to repeat. Sometimes we look at the thing we're trying to teach the machine without necessarily asking if we want to learn from it or not, or if the decisions that have been made historically are worth learning from. And when we talk about biases that can exist from like the nature of the root of our data, essentially, we talk about historical bias. So this is essentially another word for structural inequality or intersections of bias. You may have heard of like intersectional bias as a concept. So it's basically an amplifier of pretty much all kinds of problems that we're going to discuss as we go through the map. But historical bias is all the things that are different in the world now that are not necessarily due to people's personal merit or personal value, but due to the ways that they experience harms and biases due to one or many aspects of their personality or their personhood that they can't control. So that's everything from, race, gender, sex, sexuality, disability, all the things that we can think of that people may be biased against. And it is a normative statement. So again, like, it's important to grapple with the fact that when we're talking about the difference between the way the world is and the way we think it should be, we're saying that there's a misalignment here, and we're trying to identify what our values are for how we think the world should be instead. So just a couple quick examples in machine learning systems. If you've heard of this Amazon recruitment algorithm, if you want to check it out, you can see the link here. Basically, what it was doing was trying to scan CVs, and it quickly learned that men were better than women, and it quickly started to deprioritize people who had female pronouns and female words on their CV. And this is simply not to do with whether or not women are better than men or not, but because they simply didn't have sufficient representation in the data, and they were not represented because of all the reasons that women have not historically succeeded and thrived in technical STEM careers, and particularly in tech. So I'm sure you're all very familiar with the number of complex problems that has made the world the way it is right now, and the fact that we don't have sort of an equal number of women engineers as men is nothing to do with whether women are good at programming or not, and a lot to do with a bunch of social programming and sort of subtle and not so subtle nudges that they experience throughout their life. Another example of historical bias is, you probably heard of this one when you do that Google image search and you look for professional hair or CEO. With professional hair, you see usually white ladies' hair or sort of very fancy, slick hair looks. And with CEO, you still see, I think, mostly men, so probably 80% men. And these image searches are driven by the behavior of people on Google, which is driven by historical bias. So it's just a couple of ways to try and like help you build up your mental model of what this is. Now, mitigating historical bias is probably the hardest one, so it's good that we're doing it first. And I'd argue that this is an ongoing job, and we're not going to get it all done in one crack. It's not going to be one policy and we're done. It's going to be something that we have to continually work on and try and consider approaches to. But just a couple of ideas that I'd like to pitch you. First being that we can't measure what we can't, we can't manage what we can't measure. So if we don't know attributes of people, if we don't know if they belong to a protected class, essentially, we are not going to be able to assess whether or not we've applied bias to them or if they've had an unfair outcome. So the first thing, and this is a little bit unintuitive, I'd argue, I think that if we really want to get serious about measuring historical bias, we have to actually know what people's intersections of harm are so that we can assess it. We can do things like testing for model accuracy and for allocations across subdemographics. There's a whole world of fairness literature that looks at things like individual parity versus group parity. I can point you at it if you're curious. I'm not going to go into it here because it's too much, but I will say that model accuracy and whether or not it's allocating well across different groups is a huge field. It's churning constantly and it's very much not decided. So it's something that we're working on, but we definitely can't call it done. Another thing that we're seeing people start to do and start to talk about is this idea of encoding positive bias. So essentially, like, think about affirmative action or like quotas or other forms of policy, but instead of it being like a government policy, it's something you might actually encode into a model. So a way of injecting a positive bias to try and combat a negative bias that already existed. There's also this idea that's floating around, which is counterfactual fairness. And it's basically sort of a thought experiment, but also a mathematical formalism. It's also very interesting, but I'm not going to go into it deeply because we don't have time. The next space I want to talk to is data capture. So this is asking, looking at the world as it is, if we want to learn something about it and we're happy we can we capture this data well? And the two kinds of bias we can talk about when we think about the space of capturing the data or measuring it are measurement and sampling bias and representation bias. So measurement bias is essentially whatever techniques you're using to collect your data or to label it. There may be one or more problems in that process that cause a bias or some kind of unfairness to emerge. So there's sort of three subtypes of measurement bias that we can talk to. One is when my measurement process itself varies across groups. So say I do a face-to-face poll with one group of people and a phone call with another group of people and a Twitter poll with a third group. You would argue that I've introduced a bias because I haven't observed their data in the same way and I can't necessarily control for those changes. I might also, regardless of my measurement process, just get poor quality data across different groups or have like lumpy quality data. So it'd be really good for some groups and really poor for others, even if my methodology is good. And I may also be just oversimplifying my classifications. So I may be asking people to put themselves in buckets they don't actually align with. So just a few examples. If you've heard this Apple credit card scandal, argue that in many ways this is a measurement bias problem, and this was where at DHH tweeted out saying that his wife got a significantly lower credit rating than he did from the same Apple credit card application, despite the fact they had tied resources and there was really no in principle reason they shouldn't have gotten the same credit card limit offered. And I'd argue that in this case, what's happened is they've used what is called a noisy proxy. So they've tried to measure something, which is whether someone's creditworthy, by measuring credit they've accepted in the past. And you have to keep in mind that credit accepted is not the same thing as credit offered. So for instance, you might see that there's a tendency for men to both ask for and accept higher credit limits, and women to ask for and accept lower credit limits. But if you've only looked at the accepted credit limit, you've only learned something about their perhaps financial behavior that doesn't necessarily reflect whether they are creditworthy itself. I hope that makes sense. And another example is this algorithm, which you probably heard of, called PredPol. It's doing predictive policing. And if you are familiar with the idea of sampling or oversampling, what it's doing is saying, like the reason I would call this a measurement bias is if PredPol is looking at particular neighborhoods and like observing them for crime much more frequently, sending more police out there, the police will naturally identify more crime or more of the crime that happens because they're in those neighborhoods more frequently, which means that it becomes this feedback loop where people think, oh, these neighborhoods are going to have more crime committed in them, so we'll send more police and the police catch more crime, whether it's petty or not petty, and the feedback loop reinforces itself. So the idea that you might be measuring some groups more than other are themselves a form of bias. To mitigate measurement bias, like again, this is a deep space of work, so just keep in mind these are top level ideas. You could do a review of your sampling methodologies and ask questions about if you're doing ways to capture data that are good across all the different groups you want to try and observe. You can assess your proxy quality, so asking the question, is the thing we're learning from actually a good proxy for the fundamental quality I want to assess? And there's also this technique called generating synthetic data, which allows you to essentially bulk up your data set with fake data that will hopefully represent people who are perhaps missing and not at random in your data set. So essentially like coming up with some fake data, but in order to better represent people who live at these intersections of bias. When you're in the laboratory phase, so this is when you're building your model, your thresholds, your analytics, your algorithm. Hi.
And Laura, there you are.
Hello.
There you go. You're back.
Oh,
Thanks.
I'm back. Thank you so much. So in the labs phase, we're asking this question, now that we've got our data, can we form useful inferences from it? And in this phase, we look at aggregation bias and evaluation bias. I'm going to speed along a little bit because we've got a lot to get through. So aggregation bias is when we have this one-size-fits-all model, but it's used for groups with different, well, this is the stats term, conditional distributions, but basically what it means is you have a pattern and it doesn't neatly like cover the edges of different people's different groups. So you're basically using a pattern that doesn't match groups well, or doesn't nicely like learn about what's different about those subgroups. So to make that real, if you've heard of or read Invisible Women by Caroline Credo Perez, she goes through a ton of examples of how women's data being aggregated in with men's data fails to observe important and useful and meaningful things about the differences in behavior and physiology and medical needs of women. Another example is the skin cancer scanning apps. So what's happening with them is they tend to be very good at observing things like melanoma on white toned skin, but those same kinds of cancer appear very differently on people of color skin. So the darker toned, the less well they capture that same kind of diagnosis, which is obviously problematic. And what happens is people tend to get a diagnosis much later, and the skin cancer apps are propagating that like late capture. How do we mitigate this? You have to start by asking yourself, what are the differences in these different groups that I'm measuring, and how am I capturing them well? So you just have to start by asking yourself like this important question, like what's different and am I listening for it? You might want to be adding more detailed classifications, like more columns to your database. And if you can't do those first two things, at least try and identify for whom your model performs well. So if you are that skin cancer scanning app and you know you don't perform well for people of color, you should at least be giving a warning to someone if they upload their photo and it's for a skin tone you can't do well. So at the very least, own it when you're not doing it well. Evaluation bias is when you have an evaluation or benchmark that doesn't represent the target population or doesn't do a good job of assessing like quality across a group of target populations. This one's a little bit abstract, but basically think about when you might have an existing academic standard and that standard may not represent women or people of color very, very well, but then that becomes a standard and everyone tries to test their new algorithm against that thing. It just means that you propagate this form of ignoring those groups because you don't have to prove that you're performing well against them because that data set doesn't have it included. So we can mitigate this by using benchmark data sets that have good representation across different groups of ethnicities and different gender representations. And we can use more granular benchmarks and do subgroup evaluation. And we can even have confidence levels for different subgroups. And finally, when we're at the factory phase, we're asking this question, can we deploy our inferences effectively? And what happens in this phase is this thing called deployment bias. So deployment bias is a mismatch between the problem a model is intended to solve and the way it's actually used. So we talk a lot about compass and recidivism risk scores. This is actually an example of many things, but including deployment bias, because these risk scores are intended to be a decision aid only. But what we see happening is people almost always follow the number because they believe the number, they think it's somehow objective. So the difference between something being a decision aid and just being the final decision is problematic in this space. Another example which I'd like to offer is, this link takes you through to a documentary on Alphago, which is fascinating. And Alphago is this game playing algorithm that beat Lee Sedol in Go, who is the South Korean world champion. And I think an interesting thing to think about there is Alphago didn't have any visible like confidence scores or graphs or anything that he could see. So when Lee was playing the machine, he was invited to treat it like a person. But I think you could ask the question if he could see the machine's confidence scores or ideas about what was happening in the world, would it demystify it? Would it have made it less scary? Would it make him maybe more confident in his own decisions? And I think that's an interesting thing to think about with deployment. So how do we mitigate it? Well, this is one that all the product people will love. We invite everybody to join in on the application design. We think about how designers and product managers and security, InfoSec people, and all the product disciplines can come in to contribute to the application design. Obviously, I don't see this happening hardly at all, but I think we really need to be doing UX research on the use of these tools in the world and understand how they're being applied. And we want to externalize model uncertainty so we don't show the world a perfect face if we know there's flaws under the covers, right? So showing people our levels of confidence and making sure that we don't present things as perfect when we know they're not. And finally, or perhaps this should be the first thing, we design our failure flows and our recourse flows and we take them seriously, because in a stochastic world, in a non-deterministic world of like statistical modeling, we have to accept that we're going to fail. Like, it's just the nature of the beast. Failure is going to happen. That was a survey of a set of types of bias, but there's actually a whole lot more. So if you want to read more, you can go to this last paper I've belonged to you. Also, shout out to Awful AI, which has a ton of great examples of this kind of stuff. A quick note that I am mapping some resources for this fair machine learning space. So if you want to have a look at what resources exist and help me make this list better, please hop online. And I'm going to just hop to the last couple of slides so that we can have some time for conversation. So I'd just like to finish off this talk by saying, I think we need to draw a line in the sand here. We are humans, we are flawed, we are squishy, and we can aspire to ethical tech even knowing that we won't be perfect at it and that it will be difficult to get right. But I think we can distinguish between saying we as individual practitioners have moral authority and say instead we claim the moral imperative. We claim the necessity to do this work, even knowing that it's difficult and there's competing concerns and that it's certainly not black and white, it's nothing but shades of gray. And I'm not going to pretend that this is easy or that the work is clear-cut or unambiguous, because it's not. But I hope I've convinced you that it's real product work and it's real engineering work. And it's about identifying trade-offs, working through use cases, and making difficult compromises. It's about staring unflinchingly at complex systems and refusing to blink. Thank you so much. That's it from me. I'm going to stop sharing so that I can see your faces and we can have a chat.
Well done. Thank you so much, Laura. That was incredibly illuminating. And as you say, there's so much there to sift through. So I feel like we have more questions, even more than usual. We did have one here. I'm just picking out of the chat for you, just around, 1 second, please. More around counterfactual fairness.
Yes.
Could you please
totally
explain
glossed
that?
over that. I was like, shit, don't have time. Yes, so it uses this space. If you've heard of Judea Pearl in the Book of Why, it uses this idea of causal modeling, which is trying to use a mathematical fairness to identify the causal factors that occurred that like created the outcome. So that's the discipline it draws on. And counterfactual fairness for machine learning space is essentially asking the question, given an individual data point, like an individual person pushed through an algorithm and they get an outcome, if you take everything and hold it steady, but move one attribute into an attribute of bias. So for example, if it was me, take me, keep everything the same, but then make my ethnicity a person of color or like a Pacific Islander or something. If you hold everything the same and push one attribute into a space of bias, will the outcome be the same? And the answer is, if the answer is no, the outcome is different after I've changed that attribute in the space of bias, which is what we call a protected attribute or a protected class, then we can say the algorithm is counterfactually unfair. And if it's yes, then we say it's counterfactually fair. So that's the gloss, but hopefully that helps.
Yeah, that does help. Thank you. We have another one here about how we might be able to get a better blend of qualitative and quantitative approaches, rather than just focusing on quantitative, and also while avoiding a critique that the qualitative component is biased or political?
Such a good question. I'm often advocating for a combination of qualitative research to boost up and enhance the quantitative signals that you're trying to assess. And I'd argue that sometimes you can't discover things unless you do that qualitative research. I don't know how you solve the problem of identity politics, so I'm not even going to try like offering. I mean, like, yes, I know that people think that UX research, that's qualitative research, can be very political or can be very like focused on like PC or like ultra left issues, and I don't think that's true. I think that if you're doing it right, you're just trying to observe people's emotional and mental states and behaviors. And it shouldn't be about politics. It should be about observing people in their natural habitat and using that data to make your product better. But that said, fixing UX research is like a whole other talk, right? So I'm going to say, like, I empathize with your pain, but I'm not sure I have a great answer for you.
That's good. Let me just see if we have anything else. We have so many. This is the problem. Just
yeah.
sifting
Oh,
through.
there are so many. I'm just having a look too. Is Black Lives Matter the result of historical and ongoing bias? That's an interesting question. I would argue yes, because a lot of the problems with race relations and like poorer outcomes for people of color worldwide, not just in America, but in Australia and the UK and elsewhere, is arguably still very much tied to the slave trade and to the history of racialism as a pseudoscientific approach to enact power from white people onto Black people. And I actually just discovered a podcast called Seeing White, which is really, really good if you want to explore the history of race as like a sort of created scientific concept and the ways that that's been used to prop up power structures. It's really interesting to explore.
Thank you. There's one here I'm just picking out that someone who's interested in your opinion on imputation of synthetic data and data transformations to mitigate historical model bias.
Yeah, I can't see the question, but if I understand it right, I think it's a really good question because like essentially you're taking a small data set and trying to like make it artificially large. And if it means that you don't have real data and you're not really observing what's happening for people from those groups, then you might be fitting your model to a very specific set of characteristics that don't reflect like the larger group of people who actually sit in that intersection. And I think it's something that can be helpful in specific models and specific circumstances, but I think it's something to use with a lot of cynicism and a lot of self-awareness and not to necessarily assume it's going to solve the problem. Particularly as if you're asking questions about how does, for instance, a disease progress differently in a Pacific Islander versus a Caucasian person, then synthetic data is going to give you nothing because it doesn't teach you anything new that you didn't already know.
Great, well, thank you. And I think that brings us to time. My head is hurting in the best possible way. So I thank you so much, Laura, for your time. We really appreciate you making the time and sharing with us all.
My pleasure.
Thank
Thanks
you
for having
kindly.
me.